quality tuition, second best in the Caribbean. So the first question today, you're going to have to solve for 4 letters at the same time. You heard me correct. There are 4 letters to solve for here. P, Q, R, and S. Now, the basis behind this question, right? You're only going to focus on the first line, obviously, for the time being. The principle with which this works behind is this. For example, if I were to ask you to solve for x plus 1 is equal to 7, I'm just saying a very, very simple equation. If you wanted to solve for x, where x was the letter that you're trying to solve for, what would you normally do? Well, you would quickly grab this 1 and throw him across to get -1. And why would you do that? Well, the reason for that, it's because since you are trying to solve for x, that means you are trying to get x on one side and everyone else on the other side. We are all familiar with that concept. So why should it be any different for a matrices question? If we are trying to solve for P, Q, R, and S, and those are the letters that we're trying to solve for, shouldn't we keep those letters on one side and throw everybody else on the other side? So it's the same concept, except it's being applied to a more complex situation. But some things will always remain the same in maths. Another similarity between these two questions, when we're throwing across the +1, didn't we get the opposite of +1, which is -1? The same thing is going to happen to the matrices. Since we want to solve for P, Q, R, and S, we're going to keep P, Q, R, and S on this side, but we're going to grab this matrix, which the examiner gave us, and we're going to throw it across on the other side. When we throw across that matrix on the other side, it's going to become the opposite of that matrix. Anybody remember from last week? What do we call the opposite of a matrix? I'll give you a hint. Starts with the letter I. What do you call the opposite of a matrix, of a particular matrix? Inverse, and you all have it correct. Great. So you all remember that from last week. So one more thing I have to advise on. When you are throwing across a matrix, it can only be thrown across one matrix. In other words, when we throw across this matrix, it has 2 places it can land. It can land quite over here when we throw him across, or it can land in between the equal sign and the matrix. So it's 2 places it can land, right? When you throw across a matrix, it has to jump over exactly one matrix. So that means today it's going to have to land over here because it has to jump across the one matrix, which is the -4, -1, -3, and 0. It has to do that. So let's go ahead with this question. So what we're going to do, we're going to grab this red matrix and throw him across. Now, when you throw across that matrix, remember we said it's going to land over here, leaving who on this side by himself? P, Q, R, and S. Could you all find the inverse of the red matrix for me, or pink, whatever color that is, and put it over here? See if you can remember from last week how to find the inverse of a matrix. So quickly go back in the notes, and it should be easy enough to remember. For the determinant, I got 7. And let me show you how I got the 7, right? Just a quick revision. You have to say 5 by 2. You must put your minus sign. And then you say -3 multiplied by -1. That's how you find the determinant of a matrix. So 5 by 2 is 10. Minus 3 by minus 1 is positive 3, but you have the annoying minus sign in the middle as part of the formula. So you get 10 minus 3, which is 7. So when you're finding the inverse and you get the determinant, you always throw it underneath a 1. The two values in the main diagonal, but the leading diagonal, we switch their position, so it's 2 and 5. The less important diagonal, remember, we do not move it. We just make each one the opposite. So the opposite of minus 3 is positive 3, and the opposite of minus 1 is positive 1. How many people got that exact answer for the inverse? Like no errors, no sign errors, nothing. It was 100% correct. Great. Now, before we move on now, right? Before we actually attempt to multiply out this madness here, right? Because all we really have to do is multiply out the yellow, sorry, that's a white matrix by the inverse. And when we multiply it out, we're going to get 4 answers. And believe me, the 4 answers will be P, Q, R, and S. But right now, this situation on the right-hand side of the equal sign looks a bit intimidating. Let's make that look a little less intimidating before we proceed. Multiplication does not care what order you multiply by. I can prove that. Let's say I have 2 by 3 by 1. 2 multiplied by 3 multiplied by 1 is 6. If you don't believe me, try 2 on a calculator. 2 by 3 by 1 is 6. Do you really think it will make a difference if I put the 3 first and then the 2 and then the 1? No, you're going to get the same exact answer. 3 by 2 by 1 in any order, anyhow you mix up those numbers, you're going to get the same answer, right? Why am I telling you that? How does that apply to this situation? Well, you'll notice you have to multiply 3 things here. The white matrix, the 1/7, and the red or pinkish matrix. But when you have this fraction in the middle, it makes it look so intimidating. Couldn't we just put the 1/7 in front, just like how we had it over here a little while? The order really doesn't matter. When we get rid of that 1/7 in the middle and put it at the beginning, to me, it looks less intimidating. And the reason for that is because now you can concentrate on multiplying the yellow by the pink, right? And after we multiply all those 2 things, we will get 4 answers. Then we will multiply all 4 answers by 1/7. In other words, we're handling the 1/7 last. Take down up to there. Then I'm going to go to the next slide. And in the next slide, we will begin multiplying out the scenario. But for those who want to take a chance and begin to multiply it out, feel free. Moving on to the next slide. So this is where we reached in the last slide. We had the 1/7 over here. I'll change that color. We had the 1/7 here and the 2, 1, 3, and 5 here. So I had asked you all to multiply out these 2 matrices here. Now, by now, everyone should be really good at multiplying on matrices. I won't be focusing on that anymore, but I'll give that a little jump start. Remember, the second matrix, you have to split it in 2. You're going to take the white matrix multiplied by the 2 and the 3 first. That will give you your first 2 answers. Then take the white matrix again, but this time multiplied by 1 and 5, the second half of the other matrix. And that will give you the other 2 answers. So I look forward to your 4 answers that go inside this empty white matrix. All right, so there's a small mistake in my working. I was changing the values, right? So somebody picked up on it. The values in the white matrices are wrong. Anybody else picked up on that? And let's change it to the correct thing. The white matrix is supposed to be -4, -1, minus 3 is 0. Correct now, guys? I think I have it correct there now. Sorry about that. And it's supposed to be 2, 1, 3, and 5. If you spot any other mistakes, please let me know. I am getting answers. I am getting minus 11 for sure. Underneath that is minus 6, then minus 9, and minus 3. Right? If you didn't get those values, double check it, right? Now remember, we have the annoying 1 on 7 on the outside here, and the annoying 1 on 7 still on the outside in the second line. So we're almost finished. Once you get those 4 answers, you just have to multiply every one, all the yellow values by 1/7. But multiplying by 1/7 really means you're dividing everybody by 7, right? So see if we can finish off the questions there. Right? Divide everyone by 7, you'll get some decimals, right? So let me begin working on those values. Get in some crazy numbers. Right? You can round them off, obviously. 11 divided by 7, you get in minus 1.57. 9 divided by 7, minus 1.26. 6 divided by 7, minus 0.86. And the last one is minus 0.43. That seems about correct. Remember in the exam, you try to go to 2 decimal places. Well, we've been through that already. Right? Try to at least go to 2 decimal places properly. Here, a little block, sorry. So officially, I guess I can write the answers like that, right? This is the answer for P, right? So P is minus 1.57, Q is minus 1.26, R is minus 0.86, and S is minus 0.43. This one here is supposed to be 1.29, not 6. My mistake. Thank you for letting me know. All right, so look at this question now, right? It looks just like the other question. But somebody had a question, like how much marks is a question like that would? You probably get about 4 to 5 marks for a question like that, right? So look at where the P, Q, R, and S are located. Remember, let's backtrack to the last question. In the last question, you notice the letters that we were trying to find came first. P, Q, R, S was the first matrix. But in this new question, the P, Q, R, and S are the second matrix. But the concept is still the same. We're still going to keep the P, Q, R, and S on one side of the equal sign, and we are still going to throw across this matrix here. When we throw across this matrix, though, remember in the last question, when we threw it across, it landed quite here. But remember the rules when throwing across a matrix. When you throw it across, you're going to get the opposite, better known as the inverse, but it can only jump across one matrix. If we throw it quite here, that means the pink matrix is jumping across 1, 2 matrices. It's not strong enough to do that. It doesn't have strong enough matrice legs, I guess, to hop across 2 matrices. It can only hop across 1. So what's going to happen when he tries to jump across? He's going to go, and then he's going to lose hope and hit the equal sign, boop, hit here, crash into here, boop, and land in between here. Obviously, he cannot fit in between here, but he would push the white matrix around to make space. And that's what's happening here. You notice that the inverse, which needs to go here, the inverse of this matrix needs to go here, and it pushed the white matrix across to make space. So you think you all can find the inverse of the pink matrix again and put it, well, where the pink brackets and dash is located? Correct? For the determinant of this matrix, again, 4 multiplied by 1, must put a minus sign. Then you multiply the less important diagonal, -2 by -3. You get 4, +6. I got -2 for the determinant. So a few people got the determinant wrong, so, check it back. Right? Double checking it, it looks correct. So put 1 and the -2 underneath. We switch the 1 and the 4. The less important diagonal, they do not move. We just make them the opposite. Right, now we're lucky that in this case here, the fraction already is flipped. So we don't have to move it. It's already in an appropriate position. So now I need for you all to take the pink matrix and multiply by the white matrix. And you're going to get 4 answers. When we get the 4 answers, then we will divide everyone by -2, and then we will have, and those will be the values of what? P, Q, R, and S. So it should be easy to complete from that point. So when we multiply these two matrices, well, these are the values I am getting. I still have to divide everyone inside here by -2, right? So if you divide everyone inside here by -2, you'll get +2.5, +4.5, -3, and -4. Obviously, this one is P, he is Q, he is R, and he is S. Right? For the, how I got the -5, remember the -3 would have to swing up to the top. So you'll have -3 on top. So you have 1 and you have -3. So 1 multiplied by 1 is 1. -3 by 2 is -6. 1 plus -6 is definitely -5. Right, so look for your errors. All right. Right, so, well, we finished this question, so we don't have to do this one here. All right, so the next thing we're going to do, right, we're going to learn what happens when we take a matrix and we multiply it by its own inverse. Something always happens when we do that. So what we are going to do, we're going to take this matrix A. So the examiner gives you matrix A. And then we are going to find the inverse of A. And then we're going to take A and multiply it by its own inverse. In other words, we're going to take A and multiply it by A -1. And whenever we do that to any pair of matrices, something always happens. We always get the same answer. So do me a favor, matrix A, copy it down and quickly find its inverse. Let's find the determinant first. Let's clarify that. The first thing we have to do is multiply the leading diagonal. So 2 multiplied by 1 minus, and then the less important diagonal, well, -4 by -1. So we're going to get 2 minus, well, -1 by -4 is +4. We're going to get -2 for the determinant. 2 minus 4 is -2, not +2. Okay? So for sure, the inverse, we take the 1, put the -2 underneath that 1, and we do some switching around of the numbers. The 1 and the 2 switch positions. The other two values don't actually move. They just become the opposite. All right, so how much people had the inverse? 100% correct. No errors, not even a sign error. Now, we're going to take the white matrix and multiply it by its inverse. So when we're multiplying it, we'll just put the fraction first, because I showed you already that you can move the fraction to the front of the multiplication. So we're taking A and multiplying it by what's left of the inverse. I would like you all to take the white portion and multiply it by the yellow portion. Forget about the fraction, leave him for last. But I guess for those who want to multiply out the final answer by 1 and minus 2, feel free. All right. By chance, did you all get this inside the brackets? Minus 2, 0, 0, minus 2. You're supposed to get that. I'm 100% sure that is correct. And what will happen now when you divide everyone inside here by minus 2, because we have the minus 2 written on the outside? We're going to get 1, 0, 0, 1. Anytime you take any matrix in the world and multiply by its own inverse, well, we're talking about 2 by 2 matrices, but this is the only one that they're going to ask you to multiply the inverse by. You will always get this pattern, always 1, 0, 0, 1. It's a special matrix. This matrix is what you call a unit matrix. All right. So anytime they say write a unit matrix, it's 1, 0, 0, 1. And if they ask you to take how you say a matrix C and multiply it by its own inverse, and you see that question is only worth 1 mark, all you have to do is write 1, 0, 0, 1. You don't have to show the working for it. But if the examiner asks you to show that you will get 1, 0, 0, 1, you have to show all the working, obviously. Usually when you have to show all the working and the examiner says so in the exam, it's going to be worth more than 1 mark. You'll probably get 3 or 4 marks for it. Right? So that's a special matrix, and put a little arrow by it and write out the words unit matrix. All right. So let's sometimes the examiner just give you some strange combination of matrices to multiply. It's not so popular in the paper twos, but it does come, right? I've seen it come a few times over the past 10 years, but it's extremely popular in the paper trees, right? Or I swear almost every year they just give you a crazy matrix to multiply. First of all, if you go back in your notes, I think the first day we did matrices, remember there's a certain condition that must be satisfied in order for 2 matrices to be compatible if they're being multiplied. Do you think these 2 matrices can be multiplied? And if so, I want a reason why or why not. Because sometimes the examiner could trick you. He will give you 2 matrices to multiply, and it's impossible to do. And of course, if it's impossible to do, you have to say, hey, this is not possible, and then give him a reason why. So let me hear your thoughts on this one. Possible or not possible? So when we're multiplying matrices, the first thing we have to do is put the size of each matrix underneath. So the 2 matrices are, the first one is how much here? The first one is a 3 by 2 matrix. Why? It has 3 rows, 1, 2, 3. 3 rows, and we have to put the rows first, and 2 columns, 1, 2. The other matrix, but you're familiar with this one. This is a 2 by 1 matrix. Anytime the 2 inner numbers are the same, it is possible. So once these 2 values are the same, it is possible. Now that we know it's possible, then how large will our answer be? Our 2 outer numbers will tell you the size of our answer. So our answer will be a 3 by 1 matrix. A 3 by 1 matrix has 1, three values in it. We need to figure out those three values. So how do we go about figuring out those three values? Well, here's what you have to do. You see the second matrix, as usual, you are going to let him swing up to the top as usual. Nothing has changed there. And the two values are going to walk across. But this time, it walks across here. The top is -5, 3. But it's going to get photocopied here and down here as well. It's going to get photocopied on each row. So that -5 and 3 is going to get photocopied here. And the -5 and 3 is also going to get photocopied here. -5 and 3. What you need to do now is multiply each pair. Think you all could do that for me? Multiply each pair in the green circles. All right, so let me just make up some space here. Right? I just need this area clear here. Right, so let's multiply each pair in the green brackets. -5 by 2. Well, I can do the multiplication quickly here. You all should have no problems with multiplication. Right, so to get the answer on the top layer, we add the two top answers. I guess then you all figure that out without my help here, right? So -10 plus 9 is -1. Then the middle number is -20 plus -3, which is -23. And then -5 plus -15, -20. And those are your three answers. Right? Not too difficult, right? Once you see one example, you're going to realize, wait, look, it's almost the same thing, except it's 3 layers this time. Do you think it's possible to multiply these two matrices? What are your thoughts? Correct. The first matrix is how much? 2 rows, 3 columns. So the first one is a 2 by 3. And the second one is a 3 by 1. 3 rows and 1 column. You notice the two inner numbers are the same. So yes, it is possible to multiply it. But the two outer numbers are 2 and 1. So our answer would be a 2 by 1 matrix. A 2 by 1 matrix only has 2 answers, one on top and one underneath. Yes, as big as these two matrices are, when you multiply it, you're only going to get 2 answers, believe it or not, a top answer and an underneath answer. So how are we going to go about this question? Usually, the second matrix only has, let me scratch off the -1. Let me just scratch that off. If it only had the -2 and the 3, won't the 3 swing up to the top? But this time, we have 2 values to swing up to the top. And that's the only difference. So the 3 will swing up to the top, and the -1 will swing up afterwards. So you have 1, 2, 3 values on top. And the 3 of them grow legs and they march across. And the -2 ends up here, the 3 ends up here, and the -1 ends up here. Then the 3 values get photocopied underneath as well. And guess what you do? Each pair, you multiply them. Okay? And to get a top answer, you add up the 3 top answers. To get the underneath answer, you add up the 3 underneath answers. Multiply out each one here. We're going to get -4, 15, -1, 0, -3, -4. We're going to add up the top. So -4 plus 15, that is 11, -1, But for some reason, I can't do this in my head tonight. Minus 4 plus 15 minus 1. I got 10 on top, right? And for the underneath answer, I'm getting minus 7. Sounds about right. Some people had the signs wrong, like they might have had positive 7 instead of minus 7, right? So that is check it back. I'm sure it's a very minor mistake. Ah, great. Reach past paper. So we can actually do past paper questions on matrices now. So that is a relief. I was hoping to reach here today, and we have. So let's look at the first past paper. Well, some of them are actual past paper questions, and some of them are past paper style questions that are fit for CXC. I want you all to try the first question for me. See if you can evaluate a squared plus b. Take a 2 minutes and let me see what you come up with. So a squared, it's easy to make the mistake and say, well, I'm going to square every one in a and get the 1 is 16. I just showed you that. But doesn't a squared means a multiplied by another a, and then whatever we get, we will add it to b? So a squared just means you have to take a and multiply it by itself first. 1 minus 1, 4, and 2. 1 minus 1, 4, and 2. And that's completely different from just taking each value and squaring it. So for those who did it wrong, right, you realize the question is not a short question. What you're supposed to do first is work out the a multiplied by a first. When you do that, then when you multiply a by a, you're going to get 4 answers. Then take those 4 answers and add it to b. The addition part is easy. Okay, so good luck. Just split this one down the middle and break it up into 2 portions. When you multiply a by a, I am getting minus 3, 12, and 0. Looking correct so far? That's only for a multiplied by a, the a squared part. But we still have to complete the question. We still have to add that to b. And the addition is easy. You just have to add everyone in the same position, right? So not too hard here. The minus 3, we added to the minus 1. We're going to get minus 4. We're going to get 15, minus 1, and 5. Looking correct there? This is my final answer. Right, so a lot of people are agreeing with it, and I'm just double checking to make sure. Yeah, it looks correct. For those who made any errors, look through the work and double check your work, and I'm sure that you'll come across your error. Right, so see if we can do this question. This question give you a little jump start. You see how you have A and B on this side? You're going to take this matrix and throw it across on the other side. Pretty much what we did at the beginning of class today. Remember, when you're throwing across a matrix, it becomes the opposite, better known as the inverse, and it can only jump across exactly one matrix. So you're keeping this entire matrix on the left-hand side because that matrix contains the A and B. So keep that matrix on the left-hand side. Right, so let's making sure that you throw it in the correct place. Did you all make sure and throw it over here after the matrix? And if you throw it after the matrix, right, that means the 12 minus 2, 15, and 3 remained here, and the inverse would go here, but we would drag the fraction in front eventually. So at least I hope you have that in place. All right, so let me just write it a little bit neater here. So the minus 2 and the 3 would remain here, and the inverse well, the 1 over whatever here. Right, so I hope you all had 4, 5 here, positive 2 and 1 here. And for the determinant, I think you all will be getting 22 for the determinant. See if you can confirm that. It's positive 22 for the determinant. Right? 2 minus signs ended up clashing. And once you have this 22, there's no need to leave it in the middle to make things look complex. Pull it in front here, and then you all know what to do. Take the black matrix and multiply by the bluish matrix. Finish it up from there. Just someone say I may have a small mistake. Yes, 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 I do have a small mistake. This 1 is supposed to be a negative 1. Begin the recording here. So when we multiply out the two matrices, before we divide it by the 22, these are the 4 answers we got. And if we divide every one inside there by 22, we're going to get 4. No, not 4. You're going to get 2 minus 1, 3 and 0. Obviously, the 3 and 0 match up. So that means the A is equal to 2 and the B is equal to minus 1. So that's your final answers. A is 2 and B is minus 1. And a lot of people had that way before me. So here's another question, right? This time you're going to be getting an expression for your answer instead of an actual value. Did so far. So all we have to do, write down an expression for the determinant. Well, let me write it a little bit bigger here for part A. It have n plus 1, it have 2, it have 2n. To find the determinant, as usual, we multiply the more important diagonal, the leading diagonal. So we're going to say n plus 1, but that whole thing gets multiplied by n. So you notice I put it in brackets before I multiplied by n, minus, and then multiply the less important diagonal, 2n multiplied by 2. So what we have to do now, every one inside here gets multiplied by n. N by n is n squared. 1 by n is n. Minus 2n by 2 is 4n. So you end up with n squared. Remember, n is really 1n. 1n minus 4n is 3n. So you get n squared minus 3n. And you cannot really simplify that. This here is the determinant of m. There's nothing you can do to simplify that, because n squared and n are different. So we're finished with part A. Now for part B, they ask us to find what? The inverse. How do you find the inverse of a matrix? Well, whatever you get for the determinant, even if it's crazy looking, you throw it underneath a 1. That was the deal. We would always throw the determinant underneath a 1. And then we do the switching around of the values, even if it's crazy looking values. The n goes here, and the n plus 1 goes over here. The other 2 values do not move. They just become the opposite. And that's it. You can't really simplify that. That's the end of the question. That's the inverse of n. How much people had that on their end, but they thought it was wrong? Well, you all should be able to do this question. Solve that simultaneous equation using the matrices method. You notice in this question, the x's are lined up on top of each other, the y's are lined up on top of each other, and the numbers are on the other side of the equal sign. So there's literally no tricks in this particular question. Let me just give you a little layout. When you're trying to solve it using simultaneous equations, remember you have a big brackets, a thin brackets, an equal sign followed by another thin bracket. You have to extract the values and make it suit that format. Good luck. So we have 7 here, minus 5 here, 3 and minus 2. Remember this value is minus 2. The x comes before the y, so the x goes on top, the y goes underneath, 6 and minus 5. You're supposed to take the matrix and throw it across on the other side. So this matrix here, throw it across on the other side. But I think the arrow is in the wrong place. How much people could agree with that? That since we want to solve for x and y, we're keeping x and y on this side. But when we throw across that matrix, it can only jump across one matrix. So that means it has to land over here between the equal sign and the 6 and the minus 5. Remember, when you throw it across, you are going to get the inverse. Let's help you out here. It will push that matrix around and make space for the inverse. 1 second. 6 and the minus 5 here, right? So you're going to place the inverse over here. Right, so good luck. That's a little help out there. What I'm getting. For the determinant, right? I'm going to get, let me see what we get here. Minus 14 minus 15. That's minus 14 plus 15. So I'm getting 1 for the determinant. How about that? That looking correct? So I'm getting 1 divided by 1. Great. Well, we couldn't ask for an easier number. The minus 2 will go here. The 7 will go here. The other diagonal, they just become the opposite. So it's 1 divided, well, 1 divided by 1 is 1. Of course, that's not going to really change anything. Inside the brackets, we're going to get minus 12 plus this one. Minus 12 plus 15. I'm going to get positive 3 on top. And I should write these brackets a little bit smaller. There's no need for them to be so large. Right? So we're going to get positive 3, like we said. And underneath is minus 5. I hope I have it correct there. And when you divide or multiply by 1, it doesn't matter. You're going to get 3 and minus 5. So that means x is 3, y is minus 5.